So today we'll start with traffic lights control. I'm going to solve it. Again, this is for beginners or non-electrical students. For them, how to approach solution to a problem. Okay. So I'm already explained basic commands. So how to use basic commands to get the final solution. So whenever problem is given to you, first of all you should count the number of inputs and outputs, right? So in this traffic lights problem, there are two inputs like start and stop. That is a control required. And there are two lanes, lane 1 and lane 2. Each lane has got three light indicators, red, yellow, then green, each lane. So total 6 LEDs are there. So I'm going to list the inputs and output first of all, and also address allocation is also important, right? So start is there and stop. So percentage IX 0.0 is there, or we'll take 1.0, that is inline modules we are taking it. And output, so there are 6 outputs are there. So what are the 6 outputs? Light indicators. So here lane 1 red, that is Q 1.0. Next is lane green, okay, and this is 1.1, 1.2, and this one is lane 2 red, this is 1.3, lane 2, this is 1.4 and 1.5. Is this clear? So first of all, number of inputs and outputs, that defines the, right? So this is done. Now you know the problem statement, working. What is the working required is, please refer the problem statement. So that means when start button is operated, any one of the lane is red and other lane is green. So that is the starting. Okay. So after that what happens? The lane which is in green, after green what happens? It is about to go to red. Okay, that means yellow, after green, yellow, then red. Once other lane is red, the lane, first lane can go to yellow, then green. Okay, so that is what the requirement. How can we do it? So let us have a background work before going to the logic. We'll have a timing diagram or timing table. So how many LEDs? 6 LEDs are there. That is, we'll take Okay, so now this is time, and this one is, okay, this is quite large. This is lane 1. I'll use short form. L1 means lane 1. Lane 1 red. Next, lane 2, sorry, lane 1 yellow. Next one is green. So instead of landscape, we'll change the layout, orientation, landscape, and make it. Okay, so in the same way, so this is lane 2, this is also lane 2. Okay, now at 0 seconds, what is the requirement? Our requirement, lane 1, for example, I'll assume lane 1 is red. Okay, that means this is on, and this one is off, and this one is off, and lane 2 green, that means it is on, and this one is off. Is it clear? According to the problem statement, if one lane is red, other lane is green, that is the starting point. Next, what is the time interval between the switching of light indicators in the problem statement? Five seconds. Okay. So that means time interval of 5 seconds. We want to change the status of LEDs, right? So that is 5 seconds. Next. So after 5 seconds, what should happen? So please refer the diagram here. See, we are assuming lane 1, this is red. This is red, this is green. At the time of start. After 5 seconds, what will happen? Lane 1 red. Okay, see, this is lane 2 road, but for the reference is this one. Okay, so that is the meaning. For lane 2, this is a reference. Okay, so we'll come back here. Lane 1 red means this is a red, this is green. That is the starting point. So after 5 seconds, what will happen? This will remain red, but this will go to yellow. Right? Say something. Yes or no? This is a very early morning. Still, you are not not active mode. Switch to active mode. Lane 1 is red. See, we are talking about LED here. See, this is lane 1 indicators. This is lane 2 indicator. Lane 1 is red, and lane 2 is green. So what will happen next after 5 seconds? This green will go off, and then yellow, because the lane 2 vehicles, it has to stop. If you give suddenly red, what happens? So there could be like skidding was possible, right? So that is why vehicles cannot stop immediately. So that is why before starting from green to red, before switching it, there is a yellow indicator is there. Okay, that means it is about to go to red. That is the indication. So after 5 seconds, green indicator goes off, and then yellow LED or yellow indicator will be on. Is okay? Any other changes? No. Any other changes after 5 seconds? So what you have to do? You have to edit the table here. After 5 seconds, what will happen? This will remain on. Okay, and if you go to the lane 2, first of all green will go off, and then yellow will be on, and all other status remain same. There is no change. Is it clear? Next, after 10 seconds of interval of time, what will happen? 10 seconds. After 10 seconds, yellow will be off, right? First of all, yellow will be off, then red will be on. Next, what are the other changes? And green remain off, red is on. Here green can be on, other line, or it is like first yellow is on. Correct, right? Not, you cannot jump from red to green directly. Correct. So yellow is on means red is off, green is off. Is it okay? No response means what? Means is it okay? Right. Next, after 15 seconds, what will happen? After 15 seconds, we are talking about, see, this will remain same. This will remain same. Lane 2 remains same, but in lane 1, yellow is off and green is on and red is remain off. Next, after 28 seconds, what happens? Green off, lane 1 green off, this one lane 2 yellow on, but red is off, green is off. No, this green on, green off, then red on, right? Here red on. Is it okay? Correct, right? Whenever green is off, other side, it is switching over to okay, this is off, right? Oh, okay, this is off. Correct, your point is correct. See, actually green is on. And after that, what happens? Green will go off in the next 5 seconds. So here no, from green it can directly go to red. From red it cannot go to directly green. If that is the case, or you can also take yellow every time, that is also possible. So you want to do that like that, we can see this is what we are designing now as per our requirement. Okay, so we'll go from the beginning. So what happens? 0 seconds. First lane 1 red is on, then green is on. After that, from green to yellow, yellow to red, and this is green, this is yellow. Okay, so from red to green also there is a yellow button, is that right? So we are talking about, this is yellow, green, red, yellow, green. Fine. Now it has to be, and this one is red, so this has to be red, right? This is not a change. Now it is correct. Next, after 25 seconds, now tell me when cycle is over. So when we get repeat same instruction, that means cycle is over, right? So after that we don't have to do like every instant of time. So only one cycle, if you do it, then reset option is there. Okay. So after 25 seconds, what happens? 25 seconds. So here lane 1 is yellow. Now lane 1 is red. Am I right? So that means this is red and all other are off, and this one should go to now yellow on, and all other are off. Have you completed this cycle? Just please check it. We started like green on. When it comes to green on again, so that completes one cycle. "30 seconds. What's the condition? 30 seconds. Now yellow will go off, green will be on. Okay. Next, so this has to be red because it's remain on. Already it is reached here. There is no change here. So this is one cycle. So there are 6 LEDs are there, 6 output is there, 6 indicators are there. So 30 seconds each. It will take 5 seconds. So 30 seconds, one cycle is completed. Is it okay? What is the problem? Now based upon this table, now we have to write the logic. Okay. So now I'll open the Indralogic. Otherwise, some students already done the programming part, means they have designed the visualization. So what I'll do, say I'll keep the same visualization, but program I'll change it. Okay, so that we can directly link it. So there are 2 groups they have done. One from Oxford, one from Oxford, actually 2 from one from Oxford and one from Dan and Sagar. So it is there. Both the designs are good. Okay. So file open. So there. First I'll save it as traffic control. Fine. So here this is a screen, but what I'll do is go to the program. In the program, I'll just delete this program. And I will add an object that is ladder programming. Okay, I'll do it from the beginning. I'll keep visualization same thing, but logic part I'm just changing it. Now tell me how many inputs? 2 inputs. It is start button is there. Address. Okay, it's not asking because the global variable it is already mentioned start and all everything. So right now I'll delete it. So now see while declaring there is option. Instead of variable means it's a local variable. So there is option here. You can select global variable. So you don't have to copy paste it again. Okay, so variable will be declared as global variable and address percentage ix 1.0. Okay, so you don't find it here. You don't find it in the address section. Okay, because it will be appear in the global variables directly it will appear. Okay. Next, we'll take one internal memory, that is hold variable, no address, okay, but we should declare it as global variable. We want to declare it as global variable. This need not to be global variable because global variable means the variables you want to share with visualization screen. In visualization screen, only physical means real input, that start, stop. Then 6 indicators are there, right? So this one you don't have to declare as a global variable. Okay. So click on OK, and then parallel contact. And this one is stop. Stop percentage ix 1.1. Correct. Next, so once this is done, so we know that hold variable is continuously on by operating start button. So that is a reference point, and I will take one on delay timer. But on delay timer, I'll take it. So here T1, no address here. Just click on OK. Then in pre-T, what is the time to be set? What is the entire cycle of operation? What is the total cycle time? 30 seconds. So T hash 30 seconds. And to read the time, we'll take one variable called D1, and D1 variable should be time. Okay. This is done. Now, after 5 seconds, 10 seconds, 15 seconds, so you want to have some output. So what I'll do is, I'll take a new rung here, new network, right click, box with EN, and here GE greater than or equal to, so I want to compare what? Time, that is T hash 5 seconds. Bottom side always constant. Okay, the top side means this one is always a variable, that is T1 dot ET. And I'll take one internal memory called M1. M1 is a memory bits, so there is no address required, and you don't have to declare as a global variable. Click on OK. Right. So after 5 seconds, we are switching on M1. That's a digital output. So like the same way, right click, box with en. How many box I'll take? Around 5, 6 I'll take it. That is GE. This is T hash 10 seconds. This is T1 dot ET. And here M2. M2 is another internal memory. M2. Is it okay? And again right click, box with en. Again GE greater than T1 dot ET. This is T hash 15 seconds, and this is M3. Click on OK. Address not required. Box with en. Again. T hash 20 seconds. This is (25 seconds). And last one, I want to have 30 seconds. So I'm going to use another. So total 6 comparator. Seconds, and this is M4, M5, next M6. Is it over? Means we're getting it. So we want to have some action, or means what is that? We want to have some outputs at the interval of 5 seconds. Okay, so those are internal variables, M1, M2, M3. Those are dummy variables, you can say. It does not have any physical significance outside. So with this, so what is our first requirement? We have to refer the table here. First requirement is L1 red and L2 green to be on. So now we will take the new network. So that means 0 seconds means what? 0 seconds means when you operate start button, immediately hold variable is high. So that is actually 0 seconds. So when you press the start button, immediately you want to have L1 red. So this is L1 red. L1 red is a variable, that is indicator. So this has to be global variable because this data should be exchanged with visualization. So go to variable, there we have to declare it as global variable, click on OK, and address, we have to type address %qx 1.0. Am I right? So you have to go the means you have to refer this one, lane 1 red, qx 1.0. Next, I can actually operate multiple outputs at the same time, but I don't do it because separate line I will take it, because it is better to off sometimes. So that is why now this is L2 green. L2 green, what is our address? Sorry, this is L2, right? Yeah, L2 green address is QX 1.5. This is L2 green percentage QX 1.5, and it has to be global variable. Is it clear? Next, after 5 seconds, what will happen? M1 will be on. Correct, right? So using M1, what I should do? I should switch off the green one. See the table. After 5 seconds, L1 is on, or it's already on, but we want to switch off green. Switch off green and switch on yellow. There are two activities. After 5 seconds, there are two changes in the table. That is, green is off and yellow is on. So off means normally closed, that is negative you have to use. That is M1. When M1 is on, it is going to switch off green. Next, M1. When M1 is on, lane 2 yellow is on. Lane 2 yellow address is percentage QX 1.4. Right? Lane 2 yellow is percentage QX 1.4. So I'll take one. Sorry, this is coil. This is lane 2 yellow. First of all, it is a global variable and percentage QX 1.4. Is it okay? Fine. So that is done. After 5 seconds, it is done. Next, after 10 seconds. After 10 seconds, what should happen? There are two changes are there. That means yellow is off and lane 2 yellow is off, but lane 1 yellow is on. Correct, right? After 10 seconds. What is the change? Red is off. Correct, right? See the changes between the 5 seconds and 10 seconds. Compare it. 5 seconds and 10 seconds. You just compare two rows. These two rows you have to compare. What is the change here? Here one change. It is, it was on, now we have to make it off. And yellow, it was off, now we have to make it yellow on. And here yellow was on, now we have to make it off. And red to be on. So these are the changes at 10 seconds. Okay. So now tell me one by one. So we'll focus on first lane 1. Okay. Lane 1, red is off. That is, after 10 seconds, which variable is on? M2. When M2 is on, what is our requirement? Lane 1 red should go off. Correct? So I type it, means M2. I'm taking negative because I want to switch off. Next, what is the other change? L1 yellow on. L1 yellow on means we have not declared it. M2, when M2 is on, L1 red, what is the address? Sorry, L1 yellow to be on. L1 yellow, what is the address? That is percentage QX 1.1. Am I right? And it has to be global. But to answer it, L1 yellow, lane 1 yellow is 1.1. Then the global variable is there declared. Next, what are the changes? 10 seconds. Red to be on, L2 red to be on, and L2 yellow to be off. L2 yellow to be off means this is M2. Right. Next. Red, adinu variable declare madilla, so we have to take a new line. So this is M2 and L1 L2 red address is 1.3. good. It is a global variable, percentage QX 1.3. So now it is done. Okay, next we'll go to the 15 seconds. 15 seconds, what is the change? Is there any change in the lane 1? Lane 1, there are two changes. What is that? L1 off, green on. So we'll do that. After 15 seconds, M3 will be on. So when M3 is on, what is the change? Lane 1 yellow off. Lane 1 yellow off. That is M3. Next, what is the change? Lane 1 green on. Lane 1 green is there? No. So we have to declare it. This is M3. So what is the address for L1 green? (1.2). First of all, we have to declare it as a global variable and percentage QX 1.2. Okay. So we'll go to the lane 2. Lane 2, any changes? No change. No change. So not required. No changes are there. Next, we'll go to the 20th seconds. 20th seconds means M4 is on. What's the change in 20 seconds? Is there any change in the lane 1? L1 green off. L1 green off. So M4. Next, L1 yellow on. No, so it is parallel. Next, is there any change in the 20th seconds? We are still in 20 seconds. Is any change in the lane 2? No. Next, 25 seconds. M5 is on. Is there any change in the lane 1? L1 red on. This is M5. Next, L1 yellow off. M5. Okay, next, any changes? L1 green is already off. Next, L2 red off. L2 red off. So this is M5. Next, L2 yellow on. L2 yellow. Okay, M5. And any changes? L2 green is already off. Next, last one, M6. No changes in the L1. So L2 green to be on, that is yellow off. L2 yellow. M6. And last one is L2 green on. L2 green. This is M6. L2 model. Okay. L2 alone. Okay. So not this one. L2 green. This is M6. Okay. So that means at last green is on. So after 5 seconds, 35 seconds, after 35 seconds, cycle should repeat. Correct, right? So box with en, ge, then t1 dot et, and this is t hash 35 seconds. So after that you are going to switch on M7. M7, it has to reset the timer. Click on OK, and just before the correct, so that it will go to this first one. Is it required or not required, right? It is same. It is same, right? So that means we can reset it M6 only. M7 instead of M7. We'll look at it later on. If you want, we can delete it. M7 not required. Now, since I've taken address 1.1, all these things, actually before only we should add the configuration. Okay, it's already added. DIDO is already added. Fine. So what is the next step? We have to link stop button, and stop button, we'll check once again. Global variable is declared. Start is declared as a global variable, but stop is not declared. Stop is declared here. Stop, that is we want to declare it as a global variable. Address is percentage ix 1.1. Now we'll go to the visualization. Okay, so here start button is here, but it's quite dark, so it's not visible there. Variables, change color, sorry, not change input. It is a push button type, so start button, but there is a difference. It is start only, but I have declared like only capital S, all others are small in letter, so there will be error, or you will not get output. Okay, and stop, I'll go to the input, only S is capital in my case. Then after that go to the lane 1. So lane 1 address, so we assume this is lane 1, and first one we'll assume either red, first one red, this one is red, okay, so this is lane 1 red. We'll go to variables, so but we have declared variable like L1 space red. If you type, even if you type mistakes, for example, all are capital letters, so it will not take it. Okay, better you can copy paste it, that is also we can do it. L1 red. Next, this is, oh sorry, this is not, we have to go to variables. This one, lane 1 yellow. Next, variables, lane 1 green. Okay, and here, look here, which is red one, this is green. So okay, here it is only here L2 green, and this one L2 yellow, and L2 red. Okay, so we have linked it. Start button, stop button on 6 LEDs, we linked it. So let us check the working. So no errors. working fine? So this is how we can link it to the visualization as well as to the main program. Is it fine? Then stop. If you press stop, the control going to stop. Okay. So this is how we should take up the project. From the point of computation, I'm just telling you. So when I given the statement to you, problem statement, you have to list the inputs and outputs, then addressing, then program, and then you have to link it to the visualization screen. This is like one kind of problems expected. Okay, so it's not like that. Maybe I can include hydraulics also. Hydraulics or VFD I can include. So we can, no? So all those who know all concepts, then only they can complete the task. Okay. Any questions? So this, whatever the steps we have done step by step, this recording I'll post it in the YouTube. Just go to that.